We're going to look at dynamic programming. And the first question is, what is dynamic programming? So DP is an optimization technique that is used to solve problems that can be broken down into overlapping subproblems. Take a note in overlapping subproblems. Instead of recomputing the same results multiple times, what it does is that it stores the results of smaller problems to avoid redundant calculations. So first thing is that it's an optimization technique, and it basically we use it to solve problems that can be broken down into overlapping subproblems. That's a second major thing. And also do take note of that. It's recomputing the same result multiple times. All right. So now that we've understood basically what DP is, the next really important question that comes up is, when can we use dynamic programming? So dynamic programming is useful in two important things that we've already mentioned, or rather highlighted from the definition. First is it's useful when the problem has overlapping subproblems. So when the problem has overlapping sub problems, and there should be an R here. And the best example to sort of basically talk of overlapping subproblems is the Fibonacci sequence. This is a more practical example of an overlapping that has overlapping subproblems. Apart from this, the second place where it is useful is when the problem exists in optimal substructure. Optimal substructure. So what this means is basically that the solution to the main problem depends on solutions to smaller problems. And some of the classic examples of where DP is used is like you've mentioned, the Fibonacci sequence is a really good example. The longest common sequence and the knapsack problem. Those are really some classic examples where this is used. So the next thing we're going to go ahead and look at is the two approaches that we use in DP, the two DP approaches. And those approaches are memoization, memoization, and the second one is tabulation. Memoization and tabulation. So memoization is a top-down approach where basically you start with the main problem, then break it down into smaller subproblems recursively. And if a subproblem has already been solved, you retrieve the result from a cache or memory instead of recomputing it. And we're going to look at it in more details in the next video. But when you talk of tabulation also builds solutions from smaller subproblems to the main problem in an iterative manner. So it follows an iterative manner, while what you've seen from memoization follows a recursive manner. So we store immediate results in a table. We usually use an array, and then we use them to build the final solution. So in tabulation here, we use an iterative approach. And when you talk of memoization, in memoization, we use a recursive approach. So it should be a U, recursive. We use a recursive approach. So we start with the main problem, break it down into smaller subproblems recursively, and if a subproblem is already solved, we retrieve it from the memory. That is basically just a quick introduction into dynamic programming. So in the next video, we're going to look at these two main DP approaches, that is memoization and tabulation. And we're also going to see an example of Fibonacci with memoization and also Fibonacci with tabulation.